Exercise 3, given a function f of x, we have to find the coordinates of the x-intercept and the y-intercept. And then they want us to find the equation of the x and the y asymptotes. Okay, so let's start with writing down the function. 2x minus 1, x plus 2. 2x minus 1, x plus 2. The name of the function is f, and it's a function of the variable x. Okay, so in A, first we have to understand what x-intercept and y-intercept mean. Well, no matter how, let's say another function, let's say this type of hyperbola. It crosses the x-axis here. Sometimes you hear roots or zeros for these points. Zeros because the y value for these points, if you go to the y-axis, is 0. The y value for this one is 0. That's why they call it zeros, or sometimes roots. This is also where the curve is intercepting the x-axis. This curve is intercepting the y-axis here, and the x value for this point, if you go until you meet the x-axis, is 0. So the x value for this y-intercept is 0. Okay, so going back to our function here, we have to find the x-intercept. So basically saying, when is f of x equal to 0? Okay, we have to solve this equation. So if we look at this, 2x minus 1 divided by x plus 2. This whole expression is equal to 0 only when the numerator is equal to 0. So we just have to solve this function. We could actually think of it like this. Okay, let's take this denominator, move it up here and multiply it. 0 times this becomes 0, so it disappears. Okay, so when 2x minus 1 is equal to 0, that's what we need to find out. So 2x minus 1 is equal to 0, and then this will lead to x is equal to, we move minus 1 to the right side, then divide by 2, x is equal to a half, 1 over 2. So this is the x-intercept. The y-intercept is when the x value is equal to 0. Okay, so we just have to find out what is the y value when x is equal to 0. So 2 times x, which is 0, minus 1 divided by 0 plus 2. Minus 1 divided by 2, so minus a half, minus 1 over 2. Okay, so now we have the x and the y-intercept. In the B question, they want us to find the equation of the x and y asymptotes. Okay, remember, let's say if this function looks something like this, we don't know, but they usually look something maybe like this, maybe like this. The asymptotes, the horizontal asymptote, I think they mean y asymptote, is this invisible line that kind of this function, if we go to the right, is getting closer and closer to this invisible line, but it never touches it. If we go to the left, this function is getting closer and closer to this invisible line, this y asymptote. That's the horizontal asymptote. We have another asymptote here, and if we keep going down, this function is getting closer and closer to this invisible line. Same thing here, we keep going up, it's getting closer and closer, but never touches this invisible line. We have to find the equation of these two asymptotes. So B, let's find the, which one should we start with? Actually, let's start with the x asymptote. We have to look at this and see if there's any x value that is where the function is not defined. Okay, so we know that we cannot divide something by 0, it's not defined. So whatever we have here divided by 0, that's not allowed. So when does x plus 2 become 0 for which value of x? That's what we need to find out. So x plus 2 is equal to 0. When does this happen? Very easy equation to solve. We move 2 to the right side and we have x is equal to minus 2. Okay, that's the x asymptote, I assume, because it's a little bit ambiguous. So you could think that x asymptote, the asymptote that is parallel to x-axis, but I think they mean this asymptote, the vertical asymptote. Okay. Then we have to look at the function again when, if we look at the two terms, the two x terms in this case, 2x and x. Just have to look at that expression, 2x over x. You can just cross out the x's, so we're left with 2 over 1. We just look at the coefficients in front of the x term. So 2 times x here actually says 1 times x, but it's not written out. So 2 divided by 1, which is equal to 2. So this means, therefore, the y asymptote is equal to y is equal to 2. That's the equation. Now let's check if we were correct. So 2x minus 1, x plus 2. X minus 1 and then x plus 2. It'll look something like this. Was that the function? X plus 2, x minus 1, x plus 2. Okay, so what did we get? Okay, let's find the intercept. So the 0, analyze graph, find the 0, it happens here. Okay, so a half, that's what we found here, and then the y-intercept is minus a half, and that looks about right. If we really want to make sure that is correct, open up a calculator page. The function is already defined. It's called f1 of x. So we would like to know f1 when x is equal to 0. And then we get the value minus 1 over 2, or minus a half. And that's exactly what we had here. Now back to the asymptotes. X is equal to 2, y is equal, minus 2, y is equal to 2. Let's start with the y asymptote. So draw this function, y is equal to 2, and looks pretty good from here. We can zoom out later, and then we have to draw or input this one, graph entry equation line, and then vertical line, x is equal to something. and x was equal to -2. Okay, I can move this out of the way. And now we look at, if we zoom out a little bit, you can see the result. We see that this function is getting closer and closer to the red line here, but it never touches it. Here it approaches the asymptote from above, it never touches it. Same thing here. So we have the asymptotes correct.